Okay, so we are going to start our unit on linear functions, and the first thing we're going to talk about is graphing linear functions. All right, and we are going to learn how to graph a linear function in slope-intercept form, standard form, or if there are special lines with equations that look a little weird. So yesterday we talked a little bit about linear functions using a Desmos Lego activity. So I want to just take a moment here to summarize what we discussed yesterday. All right, so how do I graph linear functions? So we use linear functions in a lot of different ways, but oftentimes what we do is we build models to help us make predictions. And we did that with the Lego activity. Another thing that you see sometimes is weather, where they build models and they tell us when things are going to arrive, like hurricanes or a thunderstorm or various things like that. So we use models to help us make predictions, and right now we're talking about linear models, but there are obviously other different kinds that we can do that. And by the end of this unit, we will talk about linear models and how we can build one ourselves using our graphing calculators. Okay, so when we're talking about linear functions, a couple of things come up. Slope, if you remember, we use the letter M for slope, and slope is rise over run. So oftentimes we want to put it in fraction form so we can use that to plot points. The slope formula is y2 minus y1 over x2 minus x1, or also sometimes known as the change in y over change in x. That triangle means delta, it's change in, the Greek letter delta. So slope, that's a little review about slope and how we can apply it. All right, so we will learn how to graph 4 types. So these are, it says here, what types of linear equations do we need to be able to graph? The first one is slope-intercept form, which you're probably pretty familiar with. Y equals mx plus b. It's called slope-intercept form because m is your slope and b is your y-intercept. When we graph these, we start by graphing our y-intercept, and then we use our slope to get the other point. Standard form is ax plus by equals c, where a, b, and c are just numbers. So you might have like 5x plus 2y equals 7. And then to graph these, we would use something called the cover-up method, which we'll talk here later in this lesson. Okay, what types of linear equations do we need to be able to graph? Well, 2 more. These are 2 special ones that look a little bit weird, and that is horizontal lines, which you'll just see y and then a number, like y equals 5. And that's a horizontal line that crosses the y-axis at 5. If you remember b, just like here, up here where we see b is our y-intercept, so it's where it crosses the y-axis. So that graph there is a horizontal, that purple line would cross at whatever the y value would be, y-intercept value would be. And then vertical lines, A stands for our x-intercept, even though we don't see that a ton. So if you had a line x, or an equation x equals 2, then it would be a vertical line that crosses the x-axis at 2. Okay, so those are 2 special ones, and they look a little weird because you won't see 2 variables, you only see 1. Okay, so let's first talk about then how do we graph something like slope-intercept form. So here's our first one. We're going to go over that. So as I mentioned in the very first part there, we want to remember here that this is our y-intercept. That's our b. Y-intercept. Okay, and we want to start there. So that'll be like your starting spot. That's y-intercept is -1. So on the y-axis, we're going to put a dot here at -1. Okay, now we're going to go and look at what we've got here. It says the slope, I'm going to change colors here. The slope is -4. Okay, now to use this, we want to be able to, remember, slope is rise over run, so we want to convert this to a fraction. Well, it's not a fraction right now, but in order to make it a fraction, all we have to do is put a 1 underneath it. Now, I can keep the negative on the top. I can put it on the top, or I could also put it on the bottom. This is also acceptable. But remember, it's rise over run, and so then that's going to change which way you go. The one thing you cannot do is put a negative on the top and the bottom. This is a no-no. That just a negative divided by a negative is a positive. Now you've made your slope positive 4, and that's not okay. So that'll be careful that you don't do that. I'm going to do this one, negative 4 over 1. So what that means is from that green dot that I made, a rise of negative 4 means go down 4. So I'm going to go down 4 units from there. And then, so I currently would be right there. And then I want to go 1 unit positively for my run. So because it's positive, we're going to go to the right. So now I'm currently here. And now you could do that again if you'd like, but that's really all you need. So now I'm going to draw my line through those 2 dots, and I've just graphed my linear function. And make sure your line goes all the way through the graph. And I'm going to put some arrowheads on this because this goes on forever. And now I've just graphed y equals negative 4x minus 1. Okay. All right, before we get into the next thing, I want to just review something. So y-intercept, as you can see there, it's where it crosses the y-axis, and in this case, that point is 0, 2. And one thing you might notice there is, and I wrote it in blue there, is that the x value is 0. This is always the case when you have y-intercepts, is that their x value is 0. So think about any point that's on the y-axis, it always has an x value of 0. And by the same token, x-intercepts, which that one x-intercept that I have plotted there is the point 2, 0. And notice that the y value is 0. That is also the case with any point on the on the x-axis has a y value of 0. So that's important because it helps us with our next type of graphing, and that's standard form. Okay. So standard form has x and y on the same side, like you can see here, so that's how you know. So I have 4x minus 2y equals 16. And so what I'm going to do is I'm going to start by finding we'll do my x-intercept first. All right. And what we said on the previous slide is that when it's your x-intercept, that means your y value is 0. So we're going to use that fact. We're going to put a 0 right there. So we would get 4x. And then when I plug in a 0 here, I would have this, right? So now a lot of people call this the cover-up method because this right here ends up being 0. So really, that's going to disappear, and we're just going to have 4x equals 16. In other words, I'm really just covering this up and not write. That would be gone. And so they cover that up and just write this step. And then now I solve for x, divide by 4 on both sides. And so my x is 4. So now this is my x-intercept. This would be the point 4, comma 0. So I would find, how do I know that that's 0? Well, I got the y from there, the x from there. Okay? And so now I make a dot at 4, 0, and there's one of my points. Okay, now I just find the other one, the y-intercept, and we've got our other point, and we're good. So I'm going to do that now. All right. So my y-intercept, this is where x is 0. Okay? So now I'm going to plug that in here. So I would have 4 times 0 minus 2y equals 16. Okay, well 4 times 0 is 0. Again, right here, that's 0. So this is really just going to go away. So what I have, and again, that's really then covered up. So a lot of people just put their finger over that part and cover that up. And then what's left is negative 2y equals 16. Okay, and now I'm going to divide by -2 on both sides. And you could do this in your head if you needed to. It was easier. So now I have y is -8. So really this is the point. X is 0, y is -8. So on the y-axis, I'm going to find the point 0, -8. And that's right there. Okay, so now I have 2 points. When we're talking about linear functions, all you need is 2 points. So now we're just going to graph that line. Ooh. Oh, there we go, not too bad. And then put your arrowheads on there. Make sure, again, it's all the way through the graph. And we've got it. All right. Now, here are special lines that we talked about previously. So remember, we said up here, let's go back to that slide. Here's our special kind of lines. Horizontal lines, y equals b. Vertical lines, x equals a. Okay, so I've got x equals a. This is my a value. And a is where it crosses the x-axis. So I find 2, that's right here. And now that's just a vertical line that passes through 2 on the x-axis. And you've got your line. And then y equals -4. So y equals -4. There's a couple different ways you could think about this. Some people say, oh, well, that's like 0x minus 4. My slope is 0. My y-intercept is -4. Yes, that's true. So that's kind of helpful too. Then you could say, well, I know it crosses at -4. And my slope is 0, which means it's flat. Or some people just say, if I can just remember that's my y-intercept, that's my b, then you're good. And you can go from there. So these are two, notice these are a little weird because they only have one variable, just an x or just a y. So those are special cases and weird lines. Those are ones you kind of have to remember that there's something weird going on. Horizontal and vertical lines. Okay, and that's it. So now what I'd like you to do is work on graphing linear functions assignment and refresh your memory on how to go through those and re-watch this if you need to, or come back to any of these examples if you get stuck. All right, good luck.